Today in class you're going to watch 4 videos while I'm out. The first 2 videos are on solving exponential equations, and then the second 2 videos are on solving logarithmic equations. So this first video I made, the other 3 are going to be from Patrick JMT. They are also available on the website, so you can re-watch these videos as needed. So solving exponential equations of the type 1 variety, and what I mean by that is ones where they can be seen as common bases. So here's the first problem. You've got 2 to the x equals 64. And we think about 64, and can we write that in base 2? And we think real hard and say, oh wait, 64 happens to be 2 to the 6th. And so therefore I can write this as 2 to the x equals 2 to the 6th. Since the bases are the same, their exponents must be equal. So x must equal 6. And that's the end of the problem. So we were able to solve this by getting the left side of the equation and the right side of the equation with common bases. Problem number 2. I've got 3 to the x equals 243. And I think of it and I go, well, can that be written as base 3? Is it a base 3 number? And sure enough, 243 happens to be 3 to the 5th. So I can rewrite that as 3 to the x equals 3 to the 5th. The left and the right side of the equation are both base 3. So therefore the exponents are equal. X equals 5. Problem number 3. I've got 3 to the 2x plus 3 equals 81, and we recognize that 81 happens to be 3 to the 4th, so I rewrite that with common bases. 3 to the 2x plus 3 equals 3 to the 4th. So those two exponents are equal, meaning 2x plus 3 equals 4. We're going to solve for x by subtracting 3 from both sides and then dividing by 2. And we have the end of it. In problem number 4, we have 5 to the 3x equals 125. We notice that 125 is 5 to the 3rd, so we rewrite it. We have the same base on both left and right, so 3x equals 3. Divide both sides by 3 and x equals 1. The next problem. 8 to the x equals 4. And, well, neither one of those, I can't write 8 as a base 4, and I can't write 4 as a base 8, but both 8 and 4 have a common base, and that is 2. 8 is 2 to the 3rd, and 4 is 2 to the 2nd. So I rewrite that. Instead of 8 to the x, I have 2 cubed to the x, which is 2 to the 3x. Instead of 4, I write 2 squared. Now both left and right side have the same base, and therefore 3x is the same as 2. And we solve and we have x equals 2/3. For our 6th problem, we have 2 to the x equals 1 over 8. And again we say, well, how can I write 1 over 8 as base 2? And 8 happens to be 2 to the 3rd, so 1 over 8 would be 2 to the negative 3. So rewriting those, I've got x equals negative 3, and there's my final answer. Didn't have to do much solving after that. So these are 6 examples of solving exponential equations when we have the common base. In the next video from Patrick JMT, he's going to show you how to solve some exponential equations when you don't have a common base. And then there will be, like I said, there will be 2 more videos that follow that are on solving logarithmic equations. If you have any challenges or difficulties, please don't hesitate to email me your questions so we can deal with that before we come to class together on Thursday. Make sure that you watch the videos, work on the homework until the end of class time. Whatever you don't finish, you will have to finish as homework. And remember, you can re-watch these videos at home at your leisure.